Hey, hi guys. Very good morning. So let's start the session. Yeah, I want to let you know that, okay, the people who are new, I'm Gautam, so it's Siddharth Goutham. So I will be handling this session, demo session. Yesterday we had a quick demo session where we discussed about our our course content and how the flow goes on, everything. Fine. Okay, and today, I'm going to quickly have an overview, whatever we have done it yesterday, and then we will be taking it forward to the next level. Okay, so first, let me share the screen first. And if you have any queries, you can unmute it or you can talk to me directly. You can talk to me or you can send a message to me. Anything is fine for me. So let me, okay. Now, yesterday we have seen with our course curriculum and what is that we are going to cover inside this. So first, like we talked about the course, which is an enterprise advanced AI program. Here it will be 17 weeks. Officially, it will be 17 weeks. Plus, we can take it 3 weeks for the projects and all these things. We can say it as like 20 weeks max, and 3 hours per class. Okay, when we go with the official class, this is a demo session will be 2 hours, but when we go with the official class, it will be 3 hours with like weekly 6 hours we will be taking two classes per week, so 6 hours we will be taking it. So 10 weeks, we will be using it for generative AI and agentic AI with 4 projects inside that. And like 4 weeks, we are going to use it for the NA10, which is an automating the creation of your agents. And and then there will be 4 weeks where we are going to spend it on the cloud code to make ourselves comfortable with that. And remaining 2 weeks, we are going to use it for the projects. Again, here total we are going to do, this one is purely on the generative AI, agentic AI project. And this one is on the NA10 projects. And this one is like cloud code project. And then we are going to integrate to the extreme level, and we will do it a end-to-end project over here. Okay, now that is what will be. These are the concepts, the core concepts overview. First one, we will cover the generative AI. Next, we are going to cover the agentic AI. We are going to cover the NA10. Okay, and then there is a cloud code. These are the ones we are having. Okay, now what is the prerequisites like for this course? All you need is just a basics of Python. For that also, we are going to provide you like the 170 videos of over here, 170 videos, which will be completely free of cost once you enroll for this course. In that, all you have to do it is go with the fundamentals, what is required for us. If you want to go with entire 150, 170 videos, you can go through it. But for us, we require just basic Python till functions, if you are comfortable, if you have some idea till functions, that is enough for us. Okay, and as I said it, we are, as we move forward, each and every concept wherever required, we are going to cover up over there. Now, next one is LLM, that is large language model. In generative AI, we will start with the LLM. What is an LLM? How come the generative AI is different from the other concepts like machine learning, deep learning? That we are going to discuss that one today. And like, LangChain is a framework. We are going to use it in the generative AI. And then there will be a prompt templates. We are going to use it. And we are going to use it, the output parsers, chains, RAG, agentic agents, and the tools and projects. Now, again, as I told you, these are the like basic. I'm giving you the titles, you can say it, or we can call it as an abstract. Okay. Now, here, each and every concept has the sub-concepts. Okay, each concept, it will have its own sub-concepts. Like, for example, if I, as I said it, the output parser will be having, these are the sub-concepts of the output parser, like string output parser, JSON output parser, structured output parser, pydantic output parser. Like this, we will be having it. And apart from that, like if you take the chains, there are some chains are there here. Okay, I can give it over here, chains. Chains concepts, there are like, we will be having sequential chain. And we will be having parallel chain. And we will be having conditional chain. So these are kind of like, you can see it, each concept is having sub-concepts, and each this sub-concept you need to do the coding wise, we will be doing it. Okay, this I explained you yesterday. The RAG is just, it looks like a simple concept. Here, these are the concepts which are involved with the RAG. That is document loader. Inside the document loader, we are having the text loader, PDF loader, web loader, and in the text splitter, we have the recursive text splitter, character text splitter, and embedding vector database, different vector database. We are going to look at ChromaDB and like FAS, that is a Facebook vector database. We are going to look at retrievers, the different retrievers we are going to look at. So this entire concept itself is and having a sub-concepts within itself. So this is what is learned over here inside the RAG. And when it comes to the agents, again, agents will be having its own sub-concepts, like agents will be having like a simple agent connecting with the built-in tool, and there will be an agent which is connecting with the customized tool, and an agent which is connecting with the built-in and customized multiple tools, and then we are going to deal with the supervised agents. All these things we are going to cover it along with the projects over here. Now, this is a kind of a fundamentals, what is required for your generative AI. And then when you go to the agentic AI, the generative AI is kind of an prerequisites for the agentic AI. Without generative AI, we can't jump into the agentic AI, and especially when we are dealing with the land chain and land graph. These are the frameworks we are going to use it. So here, what we are going to do it is, here we have the agents. These agents will be more like an autonomous agents. Autonomous agents means which can take the decision on its own and can perform the things. That is what comes under this autonomous agents. Okay, and each agent over here, we are going to define them in the form of workflows. Okay, workflow is just like a flow chart, and we are going to define them, each agent, as a workflow. And this is implemented with the help of land graph and land chain. Land graph, land chain are both interconnected. So we use land graph and land chain together to implement our workflow. That is, workflow is nothing but our agent. Okay, agent is defined in the form of workflow, that is coding wise implemented with the help of land graph and land chain. Now, parallel workflow, this is our parallel workflows, different workflows, iterative workflow, conditional workflow, sequential workflow, all these things you are going to learn it. And then we are going to learn about the concepts about the memory. And then we are going to learn about the concepts of RAG, advanced like RAG with agentic AI and MCP. And this is a kind of an where everything we are going to code. I was saying it yesterday also. This, we are going to write the code over here. Each and everything we are going to write the code. So, and we will use the advanced RAG, advanced MCP, multi-agents RAG with MCP, and we are going to do the project. This will be our agentic AI. Okay, and we saw about the Ratan yesterday. Here, you can see this. This is the Ratan, our and this is our cloud code. So Ratan, as I told you, here we are going to, here we are going to write the code from the scratch. From the scratch, you are going to write the code and you are going to build the agents and you are going to make that agents work for us. But when it comes to the case of Ratan, as this is an automated software where we are not going to write the code from the scratch. Here, as like this, what we are going to do it is, we will be having an application over here where there will be a different agents will be placed over here, different types of agents like, and these agents we are going to drag and drop, and we will connect them over here like this. We will connect the agent, we will drag and drop these agents over here, and we are going to connect it. It is very, very simple. But here, whenever we want to customize the agent functionality, if we want to customize the agent functionality, here comes the real problem for us. Okay, so now that you can do it when you are well aware of this. Here we are, without using any drag and drop, we are building our own agents. That's what we will be doing it. Here in the Ratan, we are going to just drag and drop over here. And your cloud code is also similar kind of, but it is kind of very advanced. So when it comes to the Ratan, we will see it like 4 weeks we allocated. One is introduction to AI agent, setting up your environment, the 5 main node types, and moving data, and the loops. This is a second phase where we will handling a bit like customer data and good workflow architecture and building up the complex path. This all is the first level. We will see the basics. Okay. And the second level, we will get into a bit advanced level, the saving the data, building the complex paths. And paths is nothing but the way the execution should go on. Okay. That is nothing but you can say it as your workflows. Okay. And this is a third one, adding AI and advanced tools. So what we are going to do it is we are going to get our LLMs and we are going to get it to our N8N and we are going to make them more intelligent and how it can work. Setting up the AI nodes, giving the AI agents memory and web scraping and browsing. These all we are going to learn it over here. Each and every case we are going to learn it over here. And this we are going to do it from the scratch, where in this case we will be already the built-in tools will be there. We are going to use them and we are going to do it and with a real-time project. And when it comes to the case of agentic AI like agentic coding with the cloud code, now here you should understand, I will show you how means taking 2 or 3 popular tools like cloud code. The very popular is open code. Open code is also very much similar to that of cloud code, not as powerful as that of the cloud code, but it is still bit, it's okay. Okay. Now whenever we are going to learn the cloud code, we will be looking at the open code as well. Okay. And windsurf is there. Cursor is there. These are all pretty much you can consider as a competitors for the cloud code. Okay. Windsurf and Cursor and open code. Now, whenever we are learning this one, I will compare this one with our open code. Open code is quite cheaper and it's sometimes you can work completely free of cost over there. But this, as I told you, this will be pretty expensive. We have to enroll monthly basis, monthly base $20, approximately 2,000 to 10,000. It will goes on with. And if you want to go with the more advanced one, it will take it like up to 20,000. It will go per month. Okay, we can, if you are really wanted to work on the cloud code, I think I can strongly recommend you can spend that initial basic plan of 2,000 and you can use it for 1 month to experience the real the functionalities of the cloud code. Okay, so in this, we will start with the basics of introduction to the agentic coding, environment setup, terminal interaction, and CLI efficiency. And this is like different commands, guys, / commands, accurate. These different commands, we are going to see it. Each and every command, we are going to see it over here. And manipulating the code and visual context. Now, what is this is, we will change the existing code. Now, a website is being created or a web page is there. We are going to add a new code into that web page, okay, or new link or an image or anything. We can add it to the existing one. We don't need to do anything. Get that code, get that page and give the link, and whatever you want to give it, that you have to do it, and you can do it. Making the code change using the cloud code, how to add an image to the context, all these things. The memory and the cost optimization. Here we are going to optimize the tokens. See, as I told you, the cloud code is very expensive compared to that of other ones, but you would never regret of paying that money. That is very, very powerful, guys, very powerful. And when you are using the cloud code with their own LLMs. Okay, now today we are going to see it very detailedly how this LLMs works. But that their own LLMs are there. The cloud code is from a company called as Anthropics. If you use the Anthropics LLMs, it looks very expensive. But what I will show you is without using the Anthropics LLMs, we will use a open source LLMs, and you can use the cloud code free of cost also. That also I will show you. And again, don't forget, I will compare this one with the open code, and I will show you. And here, standardizing the project rules, how you will define the rules for a project. That's what we are going to do it. And this is the advanced development techniques of the cloud code, like architectural first engineering and strategy of long-term ask how we can allocate a long-term execution plan to a particular, that is plan mode in the cloud and ultra plan mode over here. This we are going to define it, and the custom automation, how we can automate the things, and scaling the agents and integrating them. And each and every concept, sub agents, and we will work with a team, how we can work with a workflow and customize the workers, and tools extensibility, like how we can extend the functionalities of the tool, how we can integrate with the multiple tools. All these things we are going to learn it over here. Now, this will definitely work. Okay. Now, how this program is designed is, as I told you guys, first, you are going to learn the things coding wise, literally coding wise, without touching a single tool. And once you are completed with the coding wise, everything, we are going to do it from the scratch. Okay. And everything we are going to write it from the scratch. We are going to write it. So with this, what happens, you will become expert with the coding. Okay. Now, when you go to these tools, okay, these applications, you can literally play with them. Literally, you can play, because you already coming from a core coding stuff. You can literally play with them. Okay, you can do whatever you want to do it. See, actually, this is designed for that without coding. With minimal coding, I can't say without coding, with minimal coding, you can build the agent. Now, you are an expert with the coding and you are coming to the NA10 and cloud code, then you see your confidence level. You can play with the things. Of course, you can customize the code inside this. When you are coming from the core coding background of the agentic AI and generative AI, you can play with the things. Literally, you can play with the things. Not only with this, as I told you, I will show you the WinServe. I will show you the open code very detailedly. Not as detailedly as that of our cloud code, but wherever it is required, I will compare it and I will show you. Okay. And I will show you, once you know these tools, you will know that how the other tools are working. Very easily, you can play with the things. But the very, very important thing is this. I will say it as this one. This is you are building up your foundation. Next time when you want to go to any tool or any extension of your skills, enhancing your skills, you don't need to do from the scratch. If you are directly jumping over here, then always at the back of the mind, it will be there how to do this. Okay, this is the advantage of this particular course. Okay, and as I told you, here, if you are going with the cloud code, we have to use the like these are the LLMs which are being developed by, or which are being released by Anthropics people. By default, they will be using it over here in the our cloud code, but you can go with the free LLMs. You can use this one. I will show you this, how we can do it and how you can play with the things. Okay. Now, if you are not finding any of the agents over here, the agent. You can build the agent with this, and you can integrate that code with this, and you can use that code as an agent. Now you will become kind of an expert, guys. That's what is the core purpose of this one. Okay, now as I told you, what are the required 170 videos will be provided to you. All you have to go through is these concepts. Only these concepts you have to go through it. Okay, and as I explained you yesterday, see, first AI. Now this is all about our course content. So here we are going with our foundation, fundamentals, what is required. We are doing it. So first is, what is AI? AI is the purpose of the AI is, in a simple term. Okay, now I'm not going with a very extensive definitions. In a very, very simple term, if you want me to say it, you are going to make a machine intelligent. Okay, you are going to make a machine intelligent, which can perform the task which requires human intelligence. Okay, now humans are very intelligent. We are evolving over the years. And so what the thought came down is, there are all the gadgets which are around us, all the machines which are around us. Now here we want to make these machines intelligent enough, but how intelligent? Intelligent enough as that of humans, so that it can perform the task on their own. They don't require the humans. That is what the core concepts of the artificial intelligence. And who introduced this term? The term was introduced by a gentleman by the name John McCarthy. Sorry, he's the one, John McCarthy, and he coined this term. He told about this term, or he introduced that term in 1956, and he explained the concept of artificial intelligence in 1956. And since then, the constant evolution of AI is going on. Okay, from that time till now, it is developing. Now it became very popular because everything is readily placed at here. Over the time, sometimes the data was not there, sometimes the technology was not enough, resources was not there, nothing was there. You can imagine 1956. There was no proper softwares, no proper resources, no data, nothing was there. That time they dreamt about the making an intelligent machines, which is called as artificial intelligence. Now, this is kind of, you can take it as a concept. Okay, now it's kind of a concept. Now that is implemented in 4 ways. One is machine learning. Today we are going to learn what is this all detailedly. Deep learning, generative AI, and agentic AI. Now I will not say these all are different. They are interrelated. Okay, they are all interrelated. So it will be something like this. First, AI. AI is initially implemented in using ML, but they felt there are some serious drawbacks in the ML, machine learning. So they went on to the DL, deep learning. And when they, in the deep learning, it has its own limitations. They went to the generative AI and agentic AI. Now, one thing you should understand, if you want to, AI should be implemented with ML. Initially, they went on with ML. Okay, ML was having a serious drawbacks. They went on with the DL. Now, in this case, whatever if you learn ML, your learning with the DL was pretty easy. So it is mandatory to learn ML to learn the DL. But when it comes to generative AI, it is not mandatory to learn the DL. No. You can directly jump into the generative AI. But if you want to learn the agentic AI, generative AI is mandatory. Okay, that's the way it goes on. So now, even though our course starts from here, I'm going to explain you this connectivity. Okay. Now, as I told you, there was a very popular conference happened in 1956. Okay, there was a very, very popular concept that conference happened. This conference name was Dartmouth Conference. Okay, this is the conference. The name of this conference was Dartmouth Conference. Again, this looks pretty odd. So this is held in a college called as Dartmouth. Okay, the college name is Dartmouth. This is a college name, and this college comes under the university called as MIT. So they conducted this conference and 5 years conference, and they invited best of the brains from the different parts of the world. Okay, different parts of the world. And one guy by the name John McCarthy has introduced term artificial intelligence. There was second person who came next year, 1957. He talked about the perceptron. Now, I will tell you what is this perceptron, all these things. I will explain you. This later on led to this deep learning. Okay. Now, on 58, not much happened. It was not so. There were so many people came down, but not so productive. But in 1959, a guy came down about Arthur Samuel, and this gentleman spoke about the machine learning. Okay, and we are going to talk about this one. And Alan Kay talked about the OOPS. Now, OOPS was specially designed for this. But this was not so productive. Later on, this concept was implemented in the different languages, and like Java, Python, C#, C++, all these languages, they implemented it, and it is very, very powerful. Okay. Now, initially, the AI was implemented with machine learning till 2025. Sorry, 2005. And from 2005, the deep learning came into the picture. Okay, deep learning came into the picture 2006. And once the deep learning came down, this started fading off. I can't say that completely faded off, but this is having its own importance. This is having its own importance. Okay. And from 2017, they introduced something called as transformers. Transformers are like heart for your LLM. LLM is a brain for your generative AI. Okay. This we are going to learn again detailedly today. And then in 2025, agentic AI came into the picture. Okay, now let's see them one after the other. So AI, see the definition of the AI in a simple terminology, guys. You are making a machine intelligent as that of human. Now, human is very, very complicated, but you are trying to make it. This is a concept. Now, here, if you see it, it is a field of computer science, obviously. And here it says that which focus on building the intelligent machines. That's what I was saying it constantly. It is going to build the machines, or it will provide the intelligence to the machines, which can perform tasks usually requires human intelligence. Now, example of this is, if you take it, like very popular, we can say it as driverless cars. We are having something called as driverless cars. Now, driverless cars are meant to be driven by the humans, right? It's meant to be driven by the humans. Now, these cars we are training in such a way that using the AI, what are the rules it has to follow by the humans? The same rules we will train it to the model, and model will drive the car more efficiently. Perfect rules, no question of breaking the rules. Or there are like you can take it as robotic doctors. I don't know, you must have heard about this. There are robotic doctors, not the consulting doctors. I'm talking like a robotic arms will be there over here, which will be like these are the robotic arms. You can take it, which will be having like this, a robotic arms. These arms will be doing the surgery over here. With pinpoint accuracy, it will do the perfect surgery. Of course, they will be guided with a human doctor or examined by a human doctor over here closely to monitor it, and they will be doing the surgery. This is a robotic doctors, okay, which as of now they are there for performing the surgery. Maybe very soon you can see them in the consulting as well. Okay, now that is what is an example over here. This requires human intelligence, but they require humans, but we are trained our models with this level so that these robots can drive the car, and these will do a surgeries. Okay, requires the task usually requires human intelligence. They require humans. Okay, now as of now, can you, if you can underline this point, you can do it. As of now, all this AI, what is this we talked about? Machine learning, deep learning, generative AI, agentic AI are data oriented. Means they are dependent on the data. Now, why I'm stressing the point as of now? Because very soon means not tomorrow or day after tomorrow or a year. Maybe it may take 5 years or to 10 years. You will see a concept called as, it's already there, reinforcement learning. Reinforcement learning. This is considered as a futuristic learning. We consider this as a futuristic learning. Okay. And yeah, this is futuristic, where data is not required. Where data is not required, it will train on its own experience. Now, we are going to learn about this one as well as we move forward today. So, this is the artificial intelligence is completely dependent on the data, but that is nothing but data oriented. Who is going to gather the data? Humans. That means as of now, artificial intelligence is human dependent. Okay. Now, I will tell you where exactly the data will be used. See, here you are talking about like talking that I am having a machine, and this machine we are going to make it intelligent. Now the core concept of this is how to make this machine intelligent. How you will pass the intelligence. Now intelligence is not an you can't take intelligence is not like a medicine where we will inject it into the machines, right? No. What exactly happens is you will have a model or a machine. You can consider this is a model. Now, this is a core concept, guys. Core concept I'm talking about. There will be a model, and this model, we are going to make this model intelligent over here. Okay, how we will make them intelligent? We will we will pass it on the intelligence to this. Now, the question is again the same thing. How? How? Now, for example, you want to have a vaccine. Now, we had a Chinese virus. We want to get out of that Chinese virus. We had a vaccine. How we had the vaccine? How we became immune? By injecting it. Like that, how we can make this model or a machine intelligent? That's a question. So what we will do it over here is, we will give the data. Now try to understand, this will be the core thing. This is our data. And this is our, we call it as a model. Okay. Now you may ask me, what does this model look like? This is nothing but a program which is based on the algorithm. Now, algorithm means, again, it is a formula, guys. In a simple way, it is a formula, but you have to go with a predefined step. Now, if you see a definition of the algorithm, it says that a step-by-step process of implementing a statistical formula is called as algorithm. Again, it depends, it will slightly change based on, so a step-by-step process of implementing a statistical formula that comes under the category of algorithm. Clear? Now, what happens? This is a model. Okay, this model, we are giving the data. Now, what happens? This model will extract the patterns out of this. Means it will become intelligent based on this data. Okay, like it will understand the relationship between the data. Okay, so when you are giving the data, this data, from this data, it will learn. This process, we usually call it as training. These all are the technical terminologies. This is called as training. You are going to give the data to the model, and the model will learn from the data and it will become intelligent. Now, when you ask a question to this model about this data, it will give you the answer. It will give you the answer. Okay. Now, this is our model, which is intelligent. Okay. This model is the one which plays a vital role. Okay. Now, here, when I'm talking about, when I'm making it a driverless car, again, a model will be there. This model will be trained with all the rules and regulations of a car and all the devices in the car. And this model will become intelligent with all the rules and regulations, and it will learn, it will drive. And you are going to create a model over here. This model will learn all the required knowledge. It will gather all the required knowledge, how a surgery has to be done, so with a pinpoint precision, accuracy. This is again a model over here. Clear? So here is a model. Okay, this model plays an important role. Okay. Now, this model, this data should be in the pure form. Okay, if you are giving the data with the errors, it will learn with the errors and our accuracy will be less, or our answers are not accurate. So this should be a very, very pure form. Okay. Now, to make it pure form, we use some steps called as feature engineering steps. Feature engineering steps are nothing but which make this data in the pure form, simply in the pure form. This was done in early stages, like when we were doing the machine learning. These all things we are going to do it. This is kind of stuff. Okay, that is what is actually the how we will pass it on the intelligence to the model by passing the data. This data should be in the pure form, which we are going to pass on some feature engineering steps through feature. That with that our data will be in pure form. This pure form of data we are going to give it to the their model. Model will become intelligent such a way that if you ask a question about on this data, it is going to give you the answer. Now, this is the core mechanism behind your AI. Okay, so that is what happens over here. We are making the machines intelligence, and as data plays a very vital role, we can call this as a data oriented. Okay, now next one is John McCarthy is there over here. This gentleman, John McCarthy, as I explained you, he coined the term artificial intelligence in 1956 in Dartmouth conference in MIT. And according to this gentleman, according to John McCarthy, his definition of the AI is this: exact terms. A science and engineering of making intelligent machine which can mimic humans, which can behave like humans. That is what is a definition of the John McCarthy. Now, why now? The question is why now? I told you, lack of data, lack of technology, lack of resources. Okay, the lack of funding and lack of energy, lack of resources, like you can take it, the systems, all these things. These are the major reasons why the AI was not evolved so fast in the earlier 70 years. Now it is evolving now. Okay, this is about quickly about your AI. Now, as I told you, the core mechanism is this. So this AI is, as of now, they are broadly divided into three phases. One is called as artificial narrow intelligence. Second one, artificial general intelligence. Third one, artificial super intelligence. Now, whatever we have achieved, now if you take it, if AI is about 100% is there, in this where we are standing now means I can say it around 6 to 8%. Now, whatever we are doing now, what you feel that it is really amazing in AI, then we are at very initial phase. Very, very initial phase. Okay. And this will evolve a lot and lot and lot. And as I told you, like it is already a part of our life. We can't remove it. That's for sure. If you accept, if you don't accept, with your knowledge or without your knowledge, you are going to use the AI in your life. It is like that now. Now, this whatever phase we are, this is a phase we are. Current situation. Current stage. We call it as artificial narrow intelligence. Now, this is like, if a small kid starts learning how to walk, just imagine how he will walk. He will get up, he will fall down, he will put 2 steps, he will fall down, he will put 3 steps, he will fall down, he will put 10 steps, and then he will start running. We are in that stage where we are learning how to walk. This is, and this stage will be there for at least for next a decade or so, or 10 years to 20 years, you will find it. Then we will be entering into the next phase, that is an artificial general intelligence. In this case, the AI model is equivalent to that of human. Now, in this case, AI model is dependent on human. Remember that. How? Because all the AI models over here are based on the data. So, Okay, these models are dependent on the data. That's why we are saying it is human dependent. Okay, but as we move forward, okay, into the next generation, that is artificial general intelligence, here there is no need of data, no data required over here. Okay, now, how we will do it, I will tell you. There is a specialized learning technique called as reinforcement learning that is evolving as of now. Now, in this case, your AI model will be equally intelligent as that of humans. What do you mean by that is, it can do the multiple tasks exactly like human. Now, human can drive a car, he can speak on the phone, and he knows how to show the emotions to his own people, and he can work as a professional with a company or a doctor or a police or an engineer, anything like that. So a same human can do multiple tasks. The same thing an AI model can do it. This AI model will be showing the emotions also. It will be emotionally, it is attached to the humans. Okay, so they say that in this phase, if this is a fully mature phase, you can say it as it will be somewhere around 2050. Fully matured, I'm talking about fully matured. This will be around 2050. You will see that each and every human, or each and every we can say it as each and every family will have one or more AI models. At the AI robotic models, humanoids, we call it as humanoids, which look like humans, but they are AI models. They will be, there will be at least one for the protection, for traveling, for doing the household work, or to making the kids learn, or everything they will be doing it. Multiple things they will be doing it over here. Okay, that is what it will be there. That is artificial general intelligence. Now, this is somewhere around 2050. Now, as of now, we don't have the technology or the resources as of now to get into that. Nothing is there in this phase. So we are heading towards that. As I told you, reinforcement learning is one of the things which is required for to be in this. Okay, I will explain you about reinforcement learning. Then there will be a next phase called as artificial super intelligence. Now, this phase is something like, it is kind of a robot, or you must have seen in the movies, Transformer movies. Okay, Transformer movie where the car will be transforming to a robot, and robot will be transforming to a flight, and something like that phase it is. And in this phase, all they require is to make only one AI model and finish. They are capable of doing on their own. They don't need the humans anymore at that phase. Okay, and they are expecting they will be seeing this phase at least around 75 years from now on, like somewhere around 2021, sorry, not 21st century. This is 22nd century, somewhere around this 21,000. Now it is 2000, that is 21,000 we are talking about. So this exactly, you can say it as 75 years, 200 years. Between that, you will see it. But this is a very dangerous as well as very much advanced stage, you can say it. Here, in order to combine this, there are three major technologies are evolving. One is AI, okay, artificial intelligence, plus quantum computing, quantum science or quantum computing, plus nanotechnologies. These three combination, already the people started working on this, but again, it will take a lot of time for them to go with it. First, they are maturing this, getting a very saturated or sorry, very mature or stable quantum computing. And they are evolving the nanotechnologies. Nanotechnologies is you are going to work with the smallest particles over here. And this you will combine with the AI, and then you can see it's something really amazing coming up over here in that is your AI model can transform from one thing to the another form. That will be happening over here. Okay, these are the things required for that. Okay, that is all. Now, if you ask which is a best stage, this is a best stage. You can literally feel that this is like a heaven for the humans, not this. If there is a good chance that in this case, in this phase, of course, we may not see that phase, but this phase, there is a good chance that if you're not going to control the AI, it may eradicate the complete human race. Okay, but this is the heaven, like, there won't be any human lifespan will be increased, and humans will be having enough food. We can get the maximum yield from a small place. Also, we can travel within no time from one place to another place. Entire world will become a one single colony kind of stuff. Okay, there won't be any rich or, like, I will say it like, all of them will be having enough technology to become rich over there, something like that. Okay, this is the three types. Now here it is a type of, this is a narrow where we are currently, where they are completely dependent on the humans, and this type of artificial narrow intelligence is considered as a weak AI. This you can take it as a definition. It is a type of artificial intelligence which is designed to perform simple and specific single tasks. It can be used to perform multiple narrow range of related tasks, and this type of artificial intelligence is considered as weak AI. Okay, now as I told you, this is the best. This is considered as a strong AI where they are equally intelligent. Now, it is an advanced type of artificial intelligence which is equally intelligent as that of the humans. And this is a next generation artificial intelligence, intelligent machine, which is considered as a strong AI. This system doesn't require data, as it learns by its own experience, and these system enhance their intelligence on trial and error basis. And they, as I told you, they use the reinforcement learning technique over here. Okay, and this I told you, this is a futuristic hypothetical AI system which is like very advanced, very, very advanced, which reflects the extreme level of intelligence which surpasses the collective brain power of all the humanity in ever possible field, in every possible field. That is the beauty of this. Okay, again, the people are already putting on the strict rules on this, and they are signing the things so that we should not exceed the limits. Just like everyone, like most of the countries, like top 10 or 15 countries are having, 10 countries are having nuclear power. And they put on a strict rule on that, and they are using the nuclear power for the renewable energy kind of stuff, but energy resources for the energy. But at the same time, the nuclear power as a bomb, they put on a strict restrictions. The same way they are doing it on this. The people are signing, the big companies are signing, Elon Musk, Google, Amazon, these people are signing the contracts or the bonds saying that they are not going to exceed and they are not going to develop the AI model which can harm the human race. Okay, this is what about the AI. Now, first we will see about the machine learning. Now, as I told you, initially machine learning, here I explained you. Now, we don't require machine learning for our course. Just to make you comfortable that what is machine learning, I'm giving it over here. See, this is the core mechanism I explained you. Okay. And and I told you like, okay, now this is our data, right? This is our data. We are giving the data. Now this data will be a structured data. Structured data means tabular data, guys. Okay. Your data will be in the table format. That is in a normal tabular data. We are going to use it. In the machine learning, they use the structured data, which is nothing but we call it as a tabular data. And this tabular data, we are going to give the model, and model will learn from it, and it will do the predictions. Okay. Now, again, here we are going to implement the FE, that is a feature engineering, where we are going to remove all the errors, and so that our model is, our data is very much compatible or very much clean and neat and compatible, so that our model can learn from the data. This is our model. Okay. Now, this is what happens in the machine learning. Okay, this is what happens in the machine learning. Use the structured data. Structured data means nothing but the tabular data. And this data, we are going to make it in a clean and neat phase, and then we are going to give it to this. Now, this was very popular. Even now, the people in the colleges, they are teaching it. I will not say that it is completely lost. But projects are not there real time. The jobs on this are very, very less. But if you know this, you know the fundamentals, very strong fundamentals, you will have it. But this mechanism is not used nowadays. Okay, if you want, I can show you the code. Just give me. So when it is started is, now what is machine learning is defined as, machine learning is a branch of artificial intelligence, and it is a process of developing intelligent machines which can learn by itself without explicitly programmed. That means here you are going to build the model. Okay, and you give the data. That's it. There ends your job. What happens is, this model will go through this data on its own. It will go through this data. It will understand the relationship, and it will become intelligent. It will become intelligent. This model will become intelligent. That is what happens in your machine learning. What type of data? Structured data. Now, a simple example is, if you are taking like an apartment data, like where we usually stay, apartment flat, we are having an area, we are having the flat floor, which floor the flat is, and which location the flat is, what is the age of the flat, and price. So here, this will be our data. So when you give the data to the model, okay, what the model will do is, like, the price is the one which we have to do it. Based on these parameters, the price is the one we have to predict it. So this is considered as dependent column. And these all are considered as an independent column. If you're not getting, you can ignore it. In a simple way, what your model will do is, like, it will try to analyze the relationship between first area and the price, then floor and the price, then location and the price, then age and the price, like this. This is what exactly happens. This is what is learning is done. Now, again, we are not going to make it learn. It will learn on its own. It will learn on its own. All you have to do it is give the data. Now, this term, Machine learning was first coined by a gentleman called as Arthur Samuel in the year 1959. Okay, and again in the Dartmouth conference. How this happened was, see, I will explain you. In 1952, this started in 1952. This Arthur Samuel, what he used to do it is, he used to work in the IBM. At that time, there was only one company which was related to computers, that was IBM. And when he was working with the IBM, he built a game. Now, I'm talking about the, look at the timestamp. I'm saying, look at the time. It is in the 1952. Okay, 1950s, he developed a computer game over here. This is a game he developed. And one side, the computer will be playing, another side, the human will be playing over here. That time, he was very, very proud of this game. It is purely based on the rule-based game it is. So now what happened? This game was a checkers game, which is nothing but like a chess game. You can take it as a chess game. So what exactly happened was, when these people were, this person was playing, the humans are far super intelligent, superior than this game. Okay, they were able to defeat it. Now let's take it, this is a chess game. This person were able to defeat it within like 10 moves. And next person, he came down and he played the game. He defeated in 15 moves. And next person came down and he played the game and he defeated in 12 moves. So ultimately, there is a defeat. The game was able to defeat it. They were able to defeat the game. But number of moves, like 10 moves, 12 moves, and 15 moves. Now just imagine this gentleman, okay, he came down again after 2 weeks to play the game. Again, he felt very interesting. He went and he wanted to play the game. Again, he went back after 2 weeks. Now, when he is going with the same moves, which he used it 2 weeks back, he is going with the same moves. Now the system is countering it. It is defending it. It was defending it. So this gentleman was surprised. And of course, he defeated this one, but this time not in 12 moves. It went on to 25 moves. Okay, it went on to 25 moves. This is what happened. Again, in these 2 weeks, this guy asked Arthur Samuel whether you changed anything in the program. He said, no, I never got a chance. Everyone is playing continuously. I never got a chance to change it. So what this gentleman observed is, as more and more people were playing, the system is learning, the machine is learning on its own from the whatever the experience it is provided. The machine is learning on its own. Now that is where the term machine learning came into the picture. Okay, and this gentleman again came to the Dartmouth conference, and he explained this complete structure and he displayed it also, and he showed how he wrote the code on this. The coding also he displayed, and he used an algorithm, statistical algorithm, to write the code. And since then, the machine learning became very popular. Now, Arthur Samuel coined the term machine learning in 1952 at Dartmouth conference. According to his term, the definition of the machine learning is field and study that gives the computer the capability to learn without being explicitly programmed. No need to program again and again. Once you build the model and you give the data, it will learn by its own. That is where the concept of machine learning came into the picture. Okay, and when this machine learning, now again, we can take it as this is a training process, right? This is a training process. We are going to give it. We are giving the structured data over here. Now, this training process is divided into three types. Okay. One is considered as supervised learning. Second one is unsupervised learning. And there is a reinforcement learning. These are the three learnings techniques, how you are making your model learn. Now, supervised learning means we are making the model learn under the supervision. Now, just imagine how you will make your kid or a small kid of 2 years or 3 years, how you will make him learn about the fruits or animals. You will show the picture. Okay, you will show the picture and you will tell the name like apple or orange and pomegranate or banana. Like that, you will be doing it, right? You will show the picture, you will tell the name. This type of learning is called as supervised learning. Okay, here you will see this. It is a type of learning mechanism in which machines are trained with the labeled data under the supervision. Under the supervision, we are going to train them. Under the supervision means under our guidance, we are going to train it. Now, it's like this. If this is your model, you are going to give the data. If you observe the data here, I'm giving the data picture and their name, picture and their name. Then the model will learn and it will segregate all of them into different categories. That is banana, apple, orange, and grapes, like this, after learning it. This type of learning is called as supervised learning, where we are going to give the labeled data. Data will have the label, and it is under the supervision. Supervision means under our guidance, the model will learn. We will do all the things. That is what is considered. Now, unsupervised learning, again, this supervised learning has two problem statements, regression and classification. I don't think so we require this. You can, I will tell you as we move forward, I will tell you. Unsupervised learning it is a mechanism in which the machines are trained with a unlabeled data without any supervision. Now, here, based on in unsupervised learning, machines learn from the unlabeled data based on the common features like this. Here you can see I'm giving the data, okay, mixed data without labels. Now, more model, how it will learn is based on the features. Now, this is having 3 lines, this is having 4 lines, this is in the round in the shape. Based on that, it will learn and it will segregate them. This type of data where labels are not involved, unlabeled data, that is called as unsupervised learning. Okay, this comes under the unsupervised learning. And there is one more very popular is there, that is reinforcement learning. Now, reinforcement learning, there is no data. This is a futuristic learning. We don't have anything much matured on this. This is where machines are trained with their own experience without providing any data. It will learn from its mistakes. Now, just like you, just imagine you are, as a human, you want to go to your office. Let's say you want to go to your office, and you are your first day of the office. Just say it is a new office. You are going to a new office, first day of the office, and you have to report there by 10 o'clock. And assuming that, oh, I will get out at 8:45 or 8:30, that's or 8:45 I will get out. That should be enough, 1 hour 15 minutes to reach the office. Okay, now this is your office. Let's take it. This is your office and this is your house. Now the distance between this is maybe around 15 kilometers. Now you feel that, okay, I will get out at 8:45, I will reach at 10 o'clock. That should be okay. But because of it's a prime time, it is completely heavily traffic is there. Heavy traffic is there. Okay. Now, because of this traffic, it went on, you reach the office by 10:30. Now you are late by 30 minutes, right? So what you do it is you took the permission and you explained everything. And you will learn from this mistake. Next time, next day, you will not get up at you will not get out of your house at 8:45. You will get out of the house at 8:15 because you already learned from your mistake. And then you will see that even though there is a traffic, you will be able to reach to the office on time. Okay, now this how you are learning from your mistake. The same thing your model will be learning. Suppose you can if you remember in the on the Mars, that is the planet Mars, red planet, this planet we sent a rover. Okay, we sent a rover. Now this rover, suppose you take it like in we do have enough data now. I'm talking about 2010. 2010, that is 15 years back, when we sent this rover to the Mars, we were not having any data. So what the model, this rover was doing is, it was slowly taking a steps, and it was gathering the information, and slowly, very slowly, it is taking the steps and it is gathering the information, and then it will come back to the place where it landed. And then next day from here, it will go a bit far off, and then it will take it a bit extension and it will come down over here. So this is the way it will learn slowly. Suppose if there is a big valley over here, then it will learn from its mistakes and it will not go over here. This way it will start going up over here like this. So slowly it will start learning about the area, and it will keep some key points from where it will be learning it from that mistakes, whatever mistakes it is done it. This is called as reinforcement learning, where the model will be learning based on its own errors, okay, mistakes. Now here, there is no data is required. Reinforcement learning is implemented when there is no data. Okay, in the future, that is when there is no data, now we are using it. In the future, we will go with this mechanism only. It will be something like this. This is our model. Our model we considered as an agent. It will take some action. Okay, it will take some action. It will move to a new place, and it will see that if there is any mistake is happened, if the environment where it will move on now, it is moving on the Mars, right? Mars is considered as a environment. It is moving over here slowly, and if it does any mistake, it feels that okay, there is a big danger is there, then it will learn from the mistakes and it will not go that side. That is what it will happen over here. This is the environment. This is my agent. Agent will move in the environment to reach this point. These are the mistakes. You can see it. It will take the different path to reach out to this one. It will learn from its mistake and it will do it. This is what exactly happens in the reinforcement learning. Okay. Now, as I told you, you know about the basics about the machine learning now. Okay. Now, I will give you a basic information about your deep learning. See, we know that machine learning was designed for dealing with the structured data. Okay, structured data. It was having some serious problems, machine learning. Okay, this was very popular till 2005. In 2006, the deep learning came into the picture. Now, what is the beauty of the deep learning is, first, machine learning is having some problems like it can't deal with the large volume of data. Firstly. Second one, it can't deal with the high dimensional data. Okay. And here, everything we have to do it as a human, that is feature engineering. And high dimensional data is like it can't deal with high dimensional data, like images and text data. This all it can't deal with. So these are the major drawbacks of your, it can't deal with, okay, I will put it on, can't handle large volume of data. And here it can't deal with high dimensional data. And it is no auto feature engineering. These are the three major drawbacks. Okay, especially these two are the drawbacks which we can consider it. Then, actually, in 2006, they came up with the deep learning. Now, what is this deep learning new about is they introduced something called as neural network. Okay, they introduced something called as neural network here. It is a branch of artificial intelligence and also considered as a subset of machine learning, because some of the techniques we will use it over here, machine learning, which uses multiple layers of neural network to extract high features from the raw input data. Okay, it is able to extract the features from the higher dimensional data. Okay, how? By using this neural network. There is a new concept was there. They introduced this neural network inside this. And the input data here is images and sequences. Okay, sequential data. So majorly the DL, the deep learning, was having two major fields. Okay, deep learning was having two major fields. One is called as computer vision. First one. Second one is NLP, natural language processing. Okay? NLP. Okay, deep learning, computer vision, natural language processing. Now, what this computer vision is nothing but it deals with the images. And whereas NLP deal with the text data. These are the two fields. Okay, now these are the two fields were there in our you can take it away. These are again another definition of the deep learning. It is deep learning is a type of artificial intelligence which deals with the higher dimensional data by using artificial neural network, which is used to extract the hidden features from the input data. Now, input data over here is image or the text data. That is also called as sequential data. Okay, and the deep learning is designed based on the structure of the human brain, how the human brain works. Based on that it is designed. Okay, now here you can see this deep learning deals with the two major problems. One is computer vision, second one is NLP. Computer vision, what it will do is, like, if you look at the term computer vision, vision means to see, computer means our system. So you are giving your system a vision. It can see the things. It doesn't mean to say that you are going to put the eyes to the system. That is, you are making your system can recognize the images. Okay, you can recognize the images. This is, now you are seeing computer vision is a field of artificial intelligence and deep learning, which enables the computers to see, interpret, and understand the visual data. Our visual data is nothing but images. So the computer vision is implemented with the CNN. Okay, CNN. convolutional neural network. Now, again, I will show you over here. So deep learning, as I told you, was introduced a new technique called as neural network. This is also called as artificial neural network. Artificial neural network. Okay. Now, now I will explain you why it is called as artificial neural network. This artificial neural network, they changed it a little bit and they call it as convolutional neural network, which can deal with the images. This can deal with the images, convolutional neural network. Next one is, there is one more called as recurrent neural network, which can deal with the text data. Now, again, neural network is a core concept. We call this as a artificial neural network. This artificial neural network, we enhanced a bit to make it a convolutional neural network so that it can, deal with the images. And this is the recurring neural network, which deals with the text data. Okay. Now, this is what it is. Okay. That is what it is. Natural language processing. This is deals with the RNN, LSTM, and this all. RNN is a core. RNN, they did some changes and they call it as LSTM. LSTM, they did some changes and they call it as GRE. Okay. But the core purpose of the RNN is to deal with the text data. You can see it. NLP is specialized field of artificial intelligence and deep learning, which enables the computer to understand, interpret, and generate human language. The example of this is your Siri, your Alexa, your Google Assistants. All these things you can consider as your examples of your NLP. And this example, computer vision, is implemented with the CNN, is face unlocking system, facial unlocking system. And you can see it that using the AI, we recognize the humans or faces or criminals and all those things. That is all because of the. And you are talking about the driverless cars, how the car will recognize there is a there is a vehicle in front of us. That is again computer vision. Okay, this all is under the deep learning. Okay, now if you want, I can explain you detailedly, but again, this is where we will be. I will give you. Okay, I will give you a basic information. Then you will understand why this deep learning is so popular. See, as I told you, when this machine learning was there, okay, machine learning, it was having these problems. These problems were there. Now, it doesn't mean to say that once the deep learning came, machine learning is gone. No. See, deep learning has its own drawbacks. What is that? Is it requires large data. See, our machine learning can't deal with the large data. Deep learning requires large data. Means it can't deal with the small data. So you require machine learning for the small data. Okay. So the machine learning having its own importance. It's like this, guys. See, you are having a bike today. Now, or yesterday you have a bike. Now, today you bought a car. Of course, car is an advanced version of your bike. That is, you have the 4 wheels, you can take the family, you can drive. Now, once you bought the car, it doesn't mean to say that you will never use the bike again. No, we will use the bike. Some places we can't go with the car all the time. Right. This is what exactly is like machine learning and deep learning. Deep learning is like a car, which is you can use it for the long, lengthy rides with a comfort and all those things. But when it comes to the case of some small task, you have to go with the machine learning. So machine learning was still there. And along with that, deep learning was also there over here. Now, in this, We use in the machine learning, we use the structured data. In the deep learning, our data will change. Here, the data will be our images or the text data. Just a minute. Okay, 1 second. Now, here, there is a term is there. I will tell you. So, this is again our deep learning. And this data will be images or sequential data. That is a text data. I can go with text data. Now, here there is a term is used. That is, deep learning is designed based on the structure and functionality of the human brain. See, I don't know, like if you know it, in the human brain, there is a very popular or very important component called as neuron. This is a neuron. Okay, just take it. Now, the neuron doesn't look like this. I'm just saying that is a neuron. Okay. Now, I'm giving it 4 neurons over here. Okay. Now, these neurons are interconnected like this. Okay. These are the 4 neurons. Now, this is a neuron 1, neuron 2, neuron 3, neuron 4. Now, what happens whenever you give an input to this neuron? Okay, obviously the input will be our sensors. This is, I'm talking about our neuron, multiple neurons. They are connected with each other, right? This neuron, we call it as neural network. And there, this is like neural network. Okay, clear? This we will call it as neural network. That's what I said it over here. This is our neural network. Now, what we will do it is, we will give an input to it. Let's say you are using your eyes as an input and you are giving it, you are seeing a person, let's say, for the first time. Now, what happens? This will be given to the first neuron. First neuron will extract the first level features, like let's say eyes. This second neuron will extract the second level features like nose. This one like hair. This one like maybe ears or mouth. Something like that. Like that, there will be a multiple neurons will be there. They are interconnected. And these are individual neurons which are connected. They are called as neural network. Okay. Now, as whenever you see this gentleman next time, you will recognize it, right? How you will be able to recognize? These all neurons will come together and it will help you to recognize. And because of these neurons only, sometimes if you see only eyes of a person, like your favorite hero or favorite heroine, you by looking at the eyes, you will able to recognize them, right? That is because this one will be triggered. Or if you are able to see a person is moving away from your friend is moving away, you are able to look it is from his back and you will recognize by looking at his personality. That is the different neurons, a height neuron or the hair neuron, that will come into the picture and that will recognize it. This is the way a neural network works. This is a broad view. Okay. Now, what the Jeffrey hinted, like the person who introduced father of the deep learning, his name is Jeffrey hinted. What they did it is, they created a neural network over here like this. This is an artificial. This is a natural biological neural network. Neuron, this is an artificial. Okay, like this, they did it. Like this. And of course, we are going to connect it. Now, let's take it. You are giving an image. Let's say I will get one image. Image like I will give it as rabbit. Let's take it over here. Any rabbit image. I will take one rabbit image. Let's take this image. I'm taking a screenshot of this. This is a rabbit image. Okay. Now you are giving the rabbit image as an input over here. Let's take it. Here, this is a. Now this is our artificial neuron, which we call it as perceptron. P1, P2, P3, and P4. Now, what happens when this is forwarded? Now, the image of the rabbit. First, this one will extract the features of the rabbit, like ears. And here it will extract the eyes. And here it will extract the color. And here it will extract the nose. Like this, we are going to connect it. Now, as these all are perceptrons. Perceptrons are nothing but artificial neurons. So this network, we call it as there's something wrong. I will clear it off. Okay. Okay. Now, these are artificial neurons, which we call it as perceptrons. And they are connected in a network. So we call it as artificial neural network. Okay, this is considered as artificial neural network. Hope you got it. What is an artificial neural network? Why it is connected to the human brain? Now, this neural network, they enhanced a bit to deal with images. They call it as a CNN. And when you take it, the NLP, they call it as RNN. Okay, this is the way they are going to deal with the things. Okay, now what is generative AI? Now, again, we are going to deal with generative AI very detailedly. But what is that we are coming from here, and what is so special about this? First thing, here, all the things, machine learning or deep learning, if you take it machine learning, we are giving the data to the model. We are doing the training. Okay, we are performing the training over here. Okay, in the deep learning, we are giving the data to the model. But what exactly happens in the generative AI is, first thing is, sorry, I'm going to take this. Usually, This is our data. This is our data. And this is our model. Okay, this is our model. And we are going to give the data to the model. We know it from here. Okay, now my model will learn from the data and it will become intelligent. We know it. This one, we know it. Okay. And see, the thing is, when we are giving the data to the model, this is our data. Now, this process, we will call it as training. In generative AI, first thing, they increase the size of the data. Now, here, you may get a question. See, here, whatever the size we are doing it, right? Here, whatever the size, the image, or images what we are giving, it will take, now, if you are giving very large images, like 1 lakh images or 1 crore images, this will take 1 hour or 2 hours to train it. That's it, not more than that. Okay, I'm talking about. Whereas if you are taking a structured data, it will take few seconds to train it. Few seconds time to train it. Okay. But in this case, what happens? We increase the size of the data. How much is this data means? The data which is available over the internet. Whatever the data which is available on the public domain. Okay, please note the term public domain. Whatever is available, that over the internet, that data we are giving to the model. Like usually they will say that it is approximately, the data is, you can say it as 100 zettabytes of data. Now you may ask me, what is this zettabyte? We know GB, right? We know GB. GB is, we will say it as 1 GB is nothing but 1 movie in a simple terminology. Okay, next one is, next one, 1000 GB is 1 TB, terabytes. You will find the hard disk and all these things. And next one is 1 petabytes. Petabytes is your supercomputers works on the petabytes. Okay, that's a very, very huge volume of data. Like, for example, your YouTube data will be there in the petabytes. Okay, and then there is a one more, next 1000 petabytes is called as 1 hexabyte. Hexabyte, nothing is there except then the data. And next one is 1 zettabyte. We are here, 100 zettabytes. And next one is 1 yottabyte. Till here they defined it. There are some other unofficial terminologies are there that we will discuss later, but these are the ones. Okay. Now, here we are giving this much of data, 100 zettabytes of data. Now, when you are giving to this model, and model will learn from this data. Now, this model, normal system will not work for it. No, normal system will not work. This requires a very high-end system. High-end system. What do you mean by this high-end system means? See, if you take it, a normal developer may use 16 GB or 32 GB RAM. Okay, or they may go with the 64 is very rare, the personal use or for the developer to use it. So here comes a system which is having approximately 512 to 1024 GB RAM. Now, let's take it 1024 GB RAM system is there. Now, that is very expensive, very, very expensive, first of all. So these systems you will combine together over here like this. Okay, you will combine these systems together to make it this high-end system. Multiple systems with this high-end, then they will become high-end system. Now, when you give this 100 zettabytes of data to the this one, it will take 60 to 90 days to train it. Now, if you are going with one system of 512 GB RAM, with this, if you want to train it, it will take it like 7 to 9 years to train. So we are going to make it a very high-end system in such a way that this data will be trained within 60 to 90 days. Okay. And for this training purpose, it requires a lot of resources, which are very, very expensive. Now, you and me can't do it. So this will be taken care by the big enterprise level companies like Google or Microsoft or Amazon or OpenAI. Like how much it will cost is each time when you want to train it, approximately 10 million US dollars. To train it continuously for 90 days, it will cost $10 million. If you consider like 1 million is 10 crores, then you can say it as 100 crore rupees. It will, Indian rupees, it will consider 90 to 100 crore rupees. It will take to train it one time. Now, I don't think so as an individual or a small company, they will effort this this much of amount to do it. So this can be done with the big companies. Okay. And they do it. And this, as after the training, this is called as, this model, we call it as LLM, large language model. Now you can ask me a question, why we are calling this as large language model? I will tell you. See, as I told you here, in our okay, I'm going to give it over here. Let me take a space, some space. Okay, let's take it. Here, see, this is my deep learning, right? Deep learning, when I'm giving images, usually, when we give it images over here, we call it this one as image model. Okay. Now, instead of image, we are giving our text data. Text data means it is nothing but it should be in a language. Either it is English or Hindi or Japanese or French or Russian, any language, the text data should be. There should be, text data means any language should be there. So here I'm giving the text data. When I give the text data, this model will be learning from this text. So as this is learned from this text, and this text is in a particular language, so this is also called as language model. So our NLP, here NLP, what it will do, it will, here you can see, it enables the computer to understand, interpret, and generate human language. That is, it is able, you're making your model learn the human language. So that's why this is called as language model. Okay, now just imagine, okay, and initial phase, when you are taking the data from www, that is internet. So usually that will there will be maximum data in the form of text, right? It in a particular language. That data, when you are giving to a high-end system, becomes a language model. As it is training with a large volume of data, this is called as large language model. That's why we call it as a large language model. The things what you have to remember over here is, again, I will use this one. I will explain it once we enter officially into our things. So here, this is my data. Whenever I'm giving the data to my high-end system, it is an high-end system. And this high-end system is like, as I told you, if you are taking a 512 GB, that will be a high-end system, but that system requires at least years together to train it. So we combine multiple this 512 GBs to make it a higher end system, more powerful system, so that the training period will be 60 to 90 days. So whenever this model getting trained, this is a pre-trained model. LLM is a pre-trained model. So now I'm taking it again, this one. I'm copying it. Okay, here I'm giving it. Here, I will remove all this stuff. It looks so messy. Okay, now our model is ready. After training for 90 days, let's go with the 90 days over here. My model is ready. Now, this model is already having all the knowledge what your data you provided. Okay, this model, okay, we are going to take this model, and because this is a brain, like it is having all the knowledge. This model, we will take it and we will use it in an application. Now, let's take, this is my application. I built an application. This is my application. This model, I'm getting it and putting inside this, like this. Okay, this is my pre-trained model. This is this model I'm putting inside this, sorry, inside this. Okay, now this application, if you ask a question, this application will go and ask that question over here. This will give you the answer. This is my LLM, and it will get you the answer. When you ask a question to this model, okay, this model will give you the answer. Clear? Is it fine? Now, this is how our, now this application name is ChatGPT. Now, if you want, I will show you. This I can show you in the future as well. Let's take it. I'm going with the ChatGPT over here. Sorry. This is the ChatGPT. We are using it. Now, this is a ChatGPT over here. Here you ask a question. what is distance between Earth and Sun? It is giving us average distance is this one, Earth and Sun over here. Sunlight takes about 8 minutes 20 seconds to travel from the Sun to Earth. Clear? Now, this, how you are getting it? You are asking a question to this application. This is going to this model LLM and it is getting you the information. Okay. Now you see, I will ask it, which version powered with? Which version of LLM you are powered with? You can see. See, I'm powered with GPT 5.6 Luna and a reasoning focused large language model from OpenAI. Hope you got it. Now, I will ask the question, what is and how much time it takes, or what is, or I will go with, what is travel distance between Sun and Earth? What is the travel distance between Sun and Earth? Now look at this. Okay, now observe it very carefully. The average travel distance from the Sun to Earth is about 149.6 million kilometers. If you are asking about how far the sunlight travels, it travels the same distance and takes 8 minutes. Now here, look at this one. What is the travel distance between Sun and Earth? And look at the first question. What is the distance between Earth and the Sun? Okay. Now look at the answer. Okay. Observe the answer. The average distance over here. Okay. I will take this. I'm taking this as a screenshot. It's there? No, nothing is there. No, I'm just taking it over here. Here, I'm taking it. Try to understand this point. What I'm trying to say is here. Okay. Let's go with this one. Okay. I will just put down over here. I will take some space. Here, this is the first answer. Okay. Now let's see the second answer over here. This is the second answer. This is the second answer. Now here, the things to be observed is the question is same. What is the distance between Earth? What is the travel distance between Sun and Earth? The question is same. Look at the answer. Average distance between Earth and Sun is 149 million kilometers. But here it is saying the average travel distance from Sun to Earth is about 149.6 million kilometers. Look at the formation. This is formation is different and this formation is different. Here it is saying if you are asking about sunlight travel, now here it is saying the average distance is defined as 1 astronomical unit and a standard unit used in the astronomy. And here never talked about anything about astronomical unit. And here closest distance is 147.1, farthest distance is 152. Here it is closest distance about, here look at the way it is presented. Now what I'm trying to say is, what I'm trying to show you is, these answers are not copied from anywhere. They are instantly generated. How? Based on the knowledge of this LLM, which is acquired from this data, that LLM is helping to give you the answers. And each and every time, whenever it is giving you an answer, it is just generating the answers based on its knowledge. Okay, now, for example, we had a class now. I explained you about the deep learning. Now I will ask, now I explained you complete deep learning over and like 40 minutes or so. Now I will say you, explain me the deep learning once again in exactly same terms using. Can you do that? Exact same terms. Whatever I used it, examples and same terms, everything. Can you do that? No, it is next to impossible. Not only for you, for me also. If you ask exactly same phrases, same sentence, same words, you explain it as you are the one who explained us. Now explain it exactly same means no, I can't do it. Because I'm not reading from anywhere. Whatever the knowledge is there in my brain, I'm using that knowledge and I'm framing up the sentence instantly and I'm explaining you. Okay? I'm explaining you. Now here, the same thing happening over here. This, whatever the knowledge the LLM has, that based on that, it is framing up the sentence. Overall, if you take it, it looks both are same. This is also saying 149.6 kilometers, million kilometers, 149.6 million kilometers. Both are same. Giving the overall answer is same. But look at the formation of the answer. This is, again, if you ask it again, you are going to get it like Earth and Sun distance, please. Now, here I'm getting in a different way. See, again, the question is same. A slight difference is there in the question. See, the average distance is between Sun, Earth and the Moon is this, it is saying. Again, it is missed out all the explanation, whatever it is given it. Every time you ask, it will generate a new content. Every time. Why? Because it is not getting this answer from somewhere. It is getting the answer, it is generating the answer. That is the beauty of your generative AI. Generative AI, not only this, I will ask, okay, I will give it over here a question. Generate an image of a king, Indian king or Indian Hindu king flying on elephant, or generate an Hindu king riding flying elephant. Why flying elephant? How? See, I'm taking the same question. Okay, image generation requires you to log in. Okay, I have to log in over here. That's okay. Now here, use it your login over here. Now I'm giving the same one over here. Just now, whatever we did it. Generate. Okay, got it. generate an image of Indian king flying, riding on flying white elephant. Now, what happens is you take this one, you go to the Google. Let me do this. Let it generate over here. Now, go to the Google. This is my Google over here. And I will go to the Google. It's showing Google. Now, I'm saying it over here. I'm giving it. Here, I'm not asking generate. I'm saying Indian king riding on flying white elephant. Okay. Image. Get an image of Indian king riding a flying white elephant. Now I'm just giving it over here. Here you can see the images. See here. Here I got an image. Here I got an image. Here I got it, but it is not showing it is flying. It is showing it is on the clouds. Here there is an image. Now what this is doing is it is going and trying to get the images which are available in the different websites, which is the closest match to this one. Okay. It is trying to get it. Now these are the white elephant. Here there are elephant. Here there is an elephant. Okay. Now this shows a flying elephant, but king is missing. Here is also elephant, but the king is missing. And look at this. Now let's go to this one, whether it is done it over here. See this. Can you see this? Look at the accuracy, look at the precision. If you go through it, okay, I will show you here. When you go to it, you can look at this, the elephant, which has the wings and a king riding. You can see his kingdom down over here. Everything is with a pinpoint accuracy. You can see it over here. Now, if I ask the same question again, it will not get you this one. Again, it will generate a new image over here. Okay, it will generate a new image. I think there is reset this one. Okay, let's see this. Generate another image. Now it is getting us. Just wait for a few seconds. Let's wait for a few seconds, guys. It is sketching it out. Now, if I give it same question over here, it will not going to get it another one. Get me other images of the king. See, the almost same images. Because whatever it is finding, it is getting us the same images. But in this case, it is going to get you altogether now different one. This is different. Look at this one. The king is looking this side. The elephant is slightly different. Here, the elephant is here. The elephant is slightly different over here. Can you see this? Now, this is how you will be generating the new. There is a flag over here. Flag is missing in the above one. When you look at, there will be a lot of difference. You will find it. These are not copied from one another. They are completely differently they generated. They didn't get it from any sources. It is generated based on its knowledge, what it got it. Okay, so look at the difference. Hope you got the difference between these two now. This one and this one. There's a sunlight is coming down here. It is a brighter one. Now this one is a bit. Okay. Now this is what exactly the generative AI will be doing. Now look at this. Generative AI is a branch of artificial intelligence that creates new content such as text generation, I showed you, image generation, code generation, video generation, all these things will be coming over. Okay. Okay, like this. And generative AI like regenerates the new content by learning the patterns from the training data. And generative AI is very much sensitive towards the user input, which is called as prompt. Now, this is all, whatever we are giving is considered as a prompt. This one is a prompt. Okay, this one is a prompt. Whatever we are giving it is considered as a prompt. Okay, chalo guys, I will end the session over here. Let's meet next weekend and at the pretty much same time, and we can continue with our session. And mostly, I think that next week will be the people has to enroll it, and the link will be changed. And whoever is interested now from generative AI, now I'm just gave you an overview about this. We are going to go very detailedly. What are transformers? What are self-attention? What is a generative AI? What is how it is evolved? All these things we are going to see it, and then we will enter into the coding. Okay, so this is a way we will be learning it. And if you have any questions, guys, you can bring me up or you can unmute and you can ask me any questions you have it.
Okay, my question is, once having the course, as I am a database developer, so how much of years of experience we can put as a like AI once have this course completion? How much knowledge we have after this
In
one?
the, in the generative AI, you have to keep it 3 years or 4 years max. And in agentic AI, we can keep it 1.5 year, something like that. But if you want to keep it the entire AI, so now suppose you want to keep it 6 years experience in AI, okay, 6 years. Then you have to design in such a way that you will say from past 4 years, you are working on generative AI, that is from 2022. Okay, and from 2 years, you are approximately 2 years, you are working on agentic AI. And remaining 2 years or so, you can keep your older experience, or you can say that I worked on deep learning or something like that 6 years back, 4 years back, I worked. But you should be very careful. Now, this is in the market till since 2022. So if you are going to put it anything above that, there will be question will be raised. And this is there in the market from 2025. Mid of 2024, mid it was there, and or you can say 2025. You can give it 1.5 year to 2 years. This is how you will do it. But the task after completion of the course, you can compare anyone who is having like 6 to 7 years experience on AI. You can easily handle the task whatever now this is approximately 4 years you have to keep it. So 4 year task you can easily do it, very very easily you can do it. Okay.
So I have another question.
Okay.
Like I have a very basic understanding of Python. I'm basically a Java developer from past 13 years. And since AI is evolving, like in the companies, they are focusing on more agentic AIs. And are we gonna like learn to have our own LLM, or uh, we are only learning like how LLMs work?
So if I'm not wrong, you are saying that how to develop our own LLMs?
Yeah, that's what are we gonna learn, or we are just gonna learn like how LLM works or how to train an LLM?
See, LLM is training an LLM will cost you $10 million per training.
Correct.
I don't think so. I can afford so much.
Oh, no, no,
But
no.
yeah, I can show you how a model can be trained. A model can be trained in the taking back to the deep learning. I can show you how the model can train. But the same mechanism, they will apply it over here for a large volume of data. So that LLMs, we are going to get those LLMs and we are going to use it in our projects. And for getting those LLMs, some of them are free of cost LLMs and some of them are paid LLMs. Both I will show you how to do it.
Okay.
And each and every company, they will follow the same thing, how you are going to get the LLMs and use it. But here, one of the major advantages, we are not going to go with an application which generates the code. Instead of that, we will write the code from the scratch.
Yeah, got it. Thank you. Thank you.
Okay. Any more questions, please? Any more questions? Chalo guys, I'm taking it as no from your end. So I'm ending up the session. Please coordinate if you want to get it the new link, then please coordinate with the admin people, guys. Thank you very much.